So let's finally complete this timers app on which we've been working over the last couple of sections. In this section here, we're going to complete it by adding some side effects or one specific side effect to the application, which we need for those timers to work. And in general, in this section, we'll take a look at how we can handle side effects with useEffect, with React and TypeScript. And in a separate project, we'll then also take a closer look at sending HTTP requests and fetching data and handling HTTP responses when using TypeScript. So let's start by adding a side effect to this application. And the one side effect I wanna add or manage here in this application should take place in this timer component here. Now, at the moment, this is of course a fairly trivial component, but at the moment, our application also isn't super complex. And most importantly, we can add timers that never run, and that's of course not how it should behave. Instead, the goal here in this timer component is to set a timer whenever this component is created and to show a progress bar that shows us how that timer expires. Now, for that, we can use the built-in setInterval function, which is provided by JavaScript. This function can be used to execute a certain function, which we can pass as a first argument to setInterval, every x milliseconds, every 50 milliseconds, for example. And my goal here is to use this inner function, this anonymous function here, in my case, which I'm passing to setInterval, to update some state here, to update some progress bar, which I want to show in this component. To be precise, the goal is to not show the duration here, but instead, here, I want to show a progress bar, which of course should be updated every couple of milliseconds, so that we reflect the fact that the timer is expiring, that time is running out. And actually below that progress bar, I then also do want to output the remaining time. And for both things, for the progress bar and for outputting the remaining time, I need to set an interval that updates this component every couple of milliseconds so that we can update the UI with the latest information about the remaining time. Therefore, in this component, we should also manage some state. And here I'll do that with useState instead of useReducer, but you can of course use whichever state management approach you like. Now, my idea here is that this state here manages the remaining time, and initially it should be set to the duration we receive as an input to that timer. So that's the duration the user entered into this input field here. Now, the user will enter something like 5 or 10 and will mean something like 5 or 10 seconds. But setInterval actually operates on milliseconds, and therefore I'll set this remaining time state to duration times 1000, so that I convert this duration to milliseconds. Well, and then we get back this array with exactly 2 elements, where we get the current state snapshot, so the remaining time in this case, and a state updating function, setRemainingTime could be a good name. Now, inside of this function that we pass to setInterval, I then want to call setRemainingTime to update this state every 50 milliseconds, because that's when this function will fire, every 50 milliseconds, thanks to setInterval. Now, the new state will depend on the old state, so I'll use this special function form for updating, where I got the previous remaining time, and the new remaining time, which is returned by this function here, should be the old time minus 50. Minus 50 because this interval runs every 50 milliseconds. And with that, we'll update this state. Now we could use this state to, for example, update the progress bar. Here we can set the max value to duration times 1000. So the same value we used for initializing the state. And then we set the current value to remaining state. And that should therefore then lead to a progress bar that's decreasing over time. However, you should not try to save and run this code, because this code here, specifically this code, has a huge flaw. Now, what's the problem with this interval code here? The problem is that we're executing a function every 50 milliseconds that will update the state. Okay, that's not really a problem. But the problem with that is that the state update, of course, will trigger this component function again. It will execute this component function again. And that then will set a new interval. But behind the scenes, the old interval will also still be running. And therefore we'll add more and more intervals and will effectively end up in an infinite loop due to this code, which is really not what we want here and which would break our application. Therefore, this is an example for a side effect that occurs in a component, because managing this timer is not the main task of this component, it is a side effect, and it's an example of a side effect that should be managed with help of useEffect, another hook that's provided by React and that should be imported from React therefore. Now, you'll learn more about side effects and useEffect in my course or in the official React docs, and therefore I'll not explain it in depth here in this course. The main idea behind the useEffect hook is that you pass a function as a first argument to useEffect, and then a so-called dependencies array as a second argument. And this function here will then be executed by React whenever the component function did execute, so right after the component function did execute, but only if at least one of the dependencies stored in this dependencies array did change. And if it's an empty array, you got no dependencies, therefore you got nothing that could change, and therefore this function in that case only runs once after this app component function executed for the first time. Therefore, if we now move this set interval code into this effect function here in useEffect, this code will only run once even if the component function thereafter re-renders and is re-executed because we update the state. And that therefore makes sure that we don't trigger this infinite loop and we get this unintended behavior. Now, everything I explained here is totally unrelated to the question whether you're using TypeScript with React or not. useEffect indeed is a hook that doesn't really change, no matter if you're using TypeScript or not. So the key takeaway here really is that there isn't really a difference. Nonetheless, using useEffect here is important, and with that change applied, indeed this progress bar should change every 50 milliseconds. Now, before we'll take a look at that, I also want to output the remaining time, and for that I'll add a helper constant called formatted remaining time, where I'll take my remaining time, and I just realized I called it remaining state, it should be remaining time, and I then divide it by 1000 because I of course want to output the remaining time in seconds, not in milliseconds. And I'll then call toFixed2 on that to always output a number with exactly 2 decimal places. That's what this built-in method will do. And with that, we can then output the formatted remaining time down here. And here we should also refer to remaining time instead of remaining state. If you now save that and you go back and reload, you should be able to create a timer, and you should see that the progress bar and this remaining time changes. However, you can also see that it keeps on changing even after it's done, and that's therefore also something we should take care of. So let's make sure that this timer stops once it reaches 0 and that it does not keep on going. To achieve this, we can go back to this timer component and add a if check right in here in the component function. And here I want to check if my remaining time state value is smaller or equal to 0. If that's the case, I want to stop this interval so that it doesn't execute anymore, that it doesn't continue updating this state. Now for that, of course, I need to get access to that interval, and that can be tricky because it's created inside of this nested function. Now indeed, setInterval, just like setTimeout, does return a timer reference. To be precise, a value of type number that uniquely identifies a given timer or interval. And we can then call clearInterval and pass this timer to it to stop an interval. But I don't want to do that here, but instead here in this if block. It's here where I want to call clearInterval. But timer, this constant here, is not available in here. Now we could try to create a variable, timer, and set that here, and then use it to clear this. But this variable will actually be recreated whenever this component function runs again. So it will not actually give us the timer, instead it will change all the time. Now we could move it outside of this component function, but now the problem, even if we type it correctly to get rid of the errors I'm getting, now the problem would be that this timer variable would be shared across all instances of this timer component. So if we got multiple timers, which we very likely do, because we're outputting multiple timers here, they all would be sharing one variable, and therefore we could only clear the interval of one timer, not of all timers. Therefore, that's also not a good solution. Instead, the solution you should go for here is to use a ref. Because you can use refs for more than connecting to DOM elements. We did use a ref earlier in the course to get hold of a component or element, and that definitely is their most prominent use case, but that's not all you can do with refs. Instead, here we can create a ref which will soon hold this timer reference, this timer ID here. So we create a ref here, which initially is null, but which eventually will store a value of type number. And then here in useEffect, we can set interval current equal to the value returned by setInterval. Now, if you try to do that, you'll likely get an error that we can't assign to current because it is a read-only property. And that's a weird message. Now we're getting this here because I set this initial value to null, but I then set the expected type of this ref to just number. We should change it to number or null, and that will make it clear to React in the end that this ref will initially hold a null value but will eventually receive a number, and that changing the value is fine. Now, we did not have to do that when adding a ref to a DOM element due to how the ref prop that's provided by React works internally, but we have to do it when we set a value to the ref on our own. So that's the correct generic type for useRef here. Now with that, we're storing that interval ID in this ref. And the great thing about refs is that unlike variables, they won't get recreated whenever this component function runs again. Instead, the value that we store here will stay there, and we can then use it here inside of this if block and clear the interval with the ID that's stored in there. Now, of course, that could potentially be null here, and therefore we should actually add an extra condition to this if check here and check if interval.current is truthy in the end. So if it's not null, and with that, this error here goes away. However, when you now save this all, and you reload this app and you set a new timer, you might still see something strange. For one, the timer expires super fast, too fast, actually, and it still doesn't stop. Now, that's happening because this application, this project here, uses React's strict mode. And one implication of that strict mode, or one thing that strict mode does, is that it runs every component function twice when that component is rendered. Now, therefore, it at the moment actually sets two intervals, because this effect runs twice because this component is basically mounted and then immediately unmounted and mounted again. But when the first instance is unmounted, this timer, this interval, isn't stopped. Now, React's doing that in strict mode to help us catch potential bugs in this code. And one problem we have here is that in this component here, we're not cleaning up the interval when the component unmounts. And we should be doing that. And it is pretty easy to do that. Because the great thing about the useEffect is that we can return a value in useEffect. And the value that we do return should be a function, or nothing at all. But if we return something, it should be a function. And that will be a cleanup function that's automatically called by React right before this effect function runs again, if it ever runs again, or at least right before the component unmounts. So before the component is removed from the DOM, you could say. And it's therefore here in this cleanup function where we want to clean up this interval. Now to do that, we can call clear interval here as well, and then refer to interval current. However, technically, at least theoretically, the value stored here in current could refer to a different value than it does here. Because of course the cleanup function will run at some point in the future, possibly a couple of seconds or even minutes after this main effect function ran. In the meantime, we could have changed the stored value anywhere else in the component. That's why a better practice here is to store this timer in a separate constant, which is then scoped to this overall function we pass to useEffect, and to then clear this timer. And now this error down here goes away. Of course, we should still store this timer in our interval ref though, so that we can still stop it from here. And with that addition, if we now save that and reload, and we create another new timer, you'll see that now it will run correctly, not that fast, and it will stop when it reaches 0. So that's how we solved this bug, but again, we didn't really have to do anything TypeScript specific here. Instead, we're just using some standard React features. But of course, it's also important to know about those, and it's important to know that TypeScript doesn't change too much when you're working with these features here. So now at this point, we can create multiple timers here with different durations, of course, and they run simultaneously, and they will also end simultaneously, but not all together. But of course, one thing that's not really working in this app yet is this stop timers button up here. The idea, of course, is that when we press it, we stop all running timers, and if we then press it again, we restart them. Now, for that, we already are managing this global state in this timers context file and with help of that context feature. There we have this isRunning state, which we change in that reducer function to true or false, depending on which action was dispatched, which simply depends on how this button here was clicked or what the previous state of that button was, so to say. So therefore now we have to edit the timer component to stop the timers if isRunning is false and to restart them if isRunning is true. Therefore, as a first step, we need to get access to the context, because that's where this isRunning information is managed. For that, of course, we can use the useTimersContext custom hook we created earlier in this course. From that hook, or from the result of calling that hook, we can then extract the isRunning property, which is a boolean that's either true or false. And now we can use this isRunning boolean in this effect function to set the interval if we want to start the timers, or to clear the interval and stop it therefore if we want to stop them. So we can add a if check here and check if isRunning is true, in which case I want to start my timer here and store the timer ID in my interval. But else if isRunning is false, so if it's not true, I want to call clear interval and, well, clear my timer. Now, of course, timer is scoped to this first branch of the if statement and therefore not available here, which is why I'm getting an error. And therefore here, I'll actually refer to interval current. And I'll check if the timer is not running and interval current, on the other hand, is not falsy. And we can actually get rid of this check here because, of course, since we're checking whether isRunning is truthy here in the main branch, it will be falsy in the else branch because it's a boolean value. It can only be true or false. So with that, we're cleaning up that timer if isRunning is false, but this code isn't done yet. And we're also getting a warning down here on that dependencies array. Because I explained earlier that this effect function would be re-executed by React whenever the component function executed if one of the dependencies changed. And if we got no dependencies here, of course, there is nothing that can change. Therefore, this never runs again. Hence, what we should do now is add isRunning as a dependency. Because if isRunning changes, if it was true and it is false now, this effect function of course should run again, because I do want to stop or, depending on the value of isRunning, restart the interval. So isRunning must be a dependency of this effect so that the effect function is executed again if it needs to execute again. Now, one other issue we'll have here is that timer, since it is created inside of this if branch, is now not available down here in the cleanup function. And to work around that, we can simply create it as a variable here in the effect function so that we change its scope and store the interval in that variable and give that variable a type of number because setInterval returns a value of type number. So therefore, timer should be of type number. We then store the return value of interval here, and we can use it down here. Well, and with those changes made, we should now be able to stop and start those timers. So if we reload here and we add a couple of timers here that are then running. If I stop the timers, they all stop, as you can tell. And if I click start again, they will start again. And we can also add a new timer whilst they are stopped, and it will then only start once I press start timers. And that's therefore the finished app behaving the way it should behave. So now that we found out that the useEffect hook doesn't really change much when we use TypeScript, it's time to dive into the second big topic of this section: data fetching, and how that can be done in React apps with TypeScript. Now, I will say that of course there are plenty of third-party libraries that can help you with data fetching. Most importantly, TanStack Query, which I do cover in my complete guide course, and which is an amazing library for dealing with data fetching in React apps. You strongly might want to consider using a library like this. And the great thing about TanStack Query specifically is that in their official docs, they also give you detailed instructions on how to use it with TypeScript. Though one of the most important things to keep in mind there is that generally it should work pretty well with TypeScript without you adding a bunch of custom types or complicated types or anything like that. Nonetheless, you definitely might want to check this out. In this section, we'll keep it a bit simpler and we'll implement data fetching from scratch with the native fetch API that's built into the browser. For this, I created another starting project, which you find attached, of course, also again a Code Sandbox version, and this starting project comes with two pretty basic components that got some basic prop types here, also a blog post type, because this application here, this demo application, will be about fetching some dummy blog posts, and of course also about displaying them. Now we'll do the actual fetching here in the app component, in the app.tsx file, and we'll also create a little utility function that helps us with that. So let's get started with that utility helper function. So in order to fetch data in this app here, we'll use the built-in fetch function that's provided by the browser. And since that fetch function can be a bit clunky to use or has its special nuances, I'll create a new util folder in this source folder where I'll add a http.ts file. And the goal with this file here simply is to define a little helper function that we can then use in any component of our choice to fetch data. We could create a custom hook, but here I'll simply export and create a basic async function which I'll call get, because this function should send out get HTTP requests to fetch data. I'm adding the async keyword here so that inside of the function we can use the await keyword when dealing with a promise. And we will be dealing with a promise because we'll use that built-in fetch function, which, as you can see, returns a promise. Promise is also a generic type, as you can tell by these angle brackets, and it is a generic type because it's a bit like an array. It generally is its own type, a promise, but it's a promise that will eventually yield a value. And this generic type, this related type, is that value that will eventually be yielded. It's a response object. And response is another type, just like promise, that's provided by the browser, that's built in, so to say. Now, in order to work, fetch needs a URL to which a HTTP request should be sent. And since I want to create a flexible, reusable helper function here, I'll add that URL as a parameter and set its type to string, so that we can use this URL as an argument for fetch. Now we could also add a second argument to fetch, and that would be an object that then allows us to set a body or change the HTTP method if we, for example, wanted to send a post request, and so on. But here we'll deliberately keep it simple and send a standard GET request to fetch data. Now, as a result, as mentioned, we'll get a promise, so we can use the await keyword here to handle this promise with ease and eventually get that response. So that object of type response that will be stored here in this response constant. Now that's an object created by the browser, and that is an object that, for example, has an OK property, which signals whether the request was successful or not. To be precise, whether we got back a 400-ish or 500-ish error response. So we can use this in a if check and check if the response is not OK by adding this exclamation mark in front of it, to then throw an error, a new error object, for example, if we did get an error response. Because that's the special thing about fetch. It will automatically throw an error if it fails to send a request, for example, because there is no connectivity. But it will by default not throw an error if you get back an error response. And I want my utility function to always throw an error if something goes wrong. Error response is included, and that's why I'm manually throwing an error here if we do have an error response. And here we could add a message like failed to fetch data or something like this. If we make it past this if check, we know that we had a success response, so that we got some data. We can then extract that data by calling the JSON method on that response object. At least if we get data in the JSON format. And I should name it response here as well for this to succeed. So we can call JSON if we're sending the request to an API that yields JSON data, which is the case in most React applications, and which definitely is the case here. But JSON also yields a promise. And then it will eventually yield any kind of value because, of course, TypeScript has no chance of knowing which data will eventually be returned by a backend. Therefore, I'll await this here and get back my data, but that's now of type any. Now, we could now use a third-party library like Sod to validate that data and get automatic type inference by TypeScript based on our validation results. Sod definitely is a super interesting and very popular library, which you could use for that, but you could also create a standalone course just on Sod. And Sod, just to be clear, is not related to React at all. You can use it in any TypeScript project, no matter if you're building for the server side, if you are working with Angular, if you're working with React or any other framework, or no framework at all. So you definitely can use Sod for taking a look at that data you got back and for checking its structure and getting automatic type inference. But here I'll instead add as unknown to make it clear that this data, which I get back here, is unknown to me. And unknown is better than any because with any you can access any property without an error. With unknown, you will instead get an error if you try to access a property TypeScript doesn't know about. So you get more type safety when using unknown, because it will force you to then at some point explicitly set your own types. And therefore here, I'll then return this unknown data in this utility function. So now that this get function was added, we can use it here in the app component to fetch data. And here I want to keep it fairly simple, and I simply want to fetch data when that app component is rendered. Therefore, of course, we can call get, this utility function on which we just worked, after importing it, right here in the app component. Now, the dummy API I want to use for this section here is called JSON placeholder. It's this API to which I want to send some dummy requests. You can find the URL to which the requests should be sent on their website, which is jsonplaceholder.typeicode.com. And then there you can click on guide. And it's simply this URL to which the request should be sent. So we can copy that and paste that as a value here. This will then go ahead and send such a request whenever this app component is rendered. But of course, I don't just want to send a request. Instead, I also want to use the data I get back from that request. And the ultimate goal, of course, then is to render the blog posts component and pass the blog posts that are fetched from that dummy API to that component, so that this component outputs these posts. But since, of course, sending that request takes some time, and initially we won't have any data, we'll actually have to manage some state here. For example, with help of useState. Because we'll need to re-render the component once the data is there. So therefore here, we can create some state, which we could name fetched posts, and where we have a set fetched posts state updating function. And eventually here, we want to manage a bunch of blog posts, using that type that is defined here in the blog posts TSX file and which is already being exported here. Therefore, we can simply import this blog post type from /components/blogpoststsx and then use the generic nature of useState to make it clear that eventually we'll store an array of blog posts here. Now, I'm not setting an initial value, so therefore the actual initial value is undefined. Therefore, we could also convert this to a union type to make it clear that it's also possibly undefined. But that's allowed by useState anyways, and therefore we don't have to explicitly do that. What we do have to do, though, is use the response data we get back from our own get function and update this state. And that again screams for useEffect, because otherwise we'll create an infinite loop. Because if I start calling this state updating function here after getting my response, this component function will be executed again, and therefore another request will be sent, which leads to this state being updated again and this component function running again. And of course, we don't want that infinite loop. Therefore, useEffect is the solution, again here with an empty dependencies array. And we should then send this request inside of useEffect. Now, get will also actually not return the data right away, but instead a promise. Because this get function here is marked as async, and out of the box by default, async will ensure that this function wraps any data that you might be returning into a promise. So it will always yield a promise that will then eventually resolve to the data you're returning. Therefore, we actually need to wait for this promise to resolve, which we can either do by chaining the then block or by using a wait again, which only works if we're in a function that's decorated with async though. Now we could add async to this effect function, but this is actually not allowed. Because this effect function should not return a promise. And as I just mentioned, every function you add async to will return a promise. And this effect function shouldn't do that. Instead, if it does return anything at all, it should return such a cleanup function. Therefore, here, we can't use a wait like this, but the solution is to add a nested function here inside of that effect function, which can now be marked as async, which could be called fetch posts. And then we move this await get code into this helper function, which is nested in this effect function. We then just have to call fetch posts from outside that function, but still from inside that effect function. So with that, we'll then eventually get back our data, but of course that data is unknown. Now we can find out which format that data will have by taking a look at the documentation of the API we're talking to. And here we see that this will be the output if we are looking for a single post. And if we're looking for all posts, we'll therefore get an array of objects where every object will in the end have this shape here. So every object will have an ID of type number, a user ID of type number, and then a title and a body, which are both of type string. Hence, we can add a fitting type here, for example, above the app component function, and maybe name it raw data blog post. So the raw data we're getting back from the backend. And this will be an object type where, as I just mentioned, we'll have an ID of type number, we'll have a user ID of type number, and here it's important to recognize that user ID here is written like this with a lowercase d. We'll then have a title of type string and this body property, which also holds a value of type string. And that's what we'll get back, or to be precise, we'll get back an array of such objects. Therefore, we can let TypeScript know about that. We can add as raw data blog post array after this get call here. Now, after hitting the auto format shortcut, my IDE automatically added a pair of parentheses here around that await get call to make it clear that it's the result after waiting for the response that will be of type raw data blog post array. And that's then the type of data of this data constant. So therefore now with that, we have to convert that data into an array of blog posts that have this format. So just an ID, no user ID, and a title, but then no body field, but instead a text field of type string. So the fetched data must be converted. Now converting fetched data is a pretty common task. And it's also pretty straightforward to do. We can add a new constant here, blog posts, for example, where we use the data, which is this array of raw data blog posts, and where we then call the map method. And the map method, of course, is a built-in method that will yield a new array of data. It will be executed for every entry in data, so for every raw post, so to say. And as a result, I want to return a new object for every raw post where I set the ID to rawPost.id, where I set the title to rawPost.title, and where I set the text property to rawPost.text. Sorry, rawPost.body, of course. Now we should also add an explicit type annotation here to make it clear that blog posts in the end should be an array of blog posts, like this. This will ensure that we'll get an error if we make a mistake during this conversion here. However, the only error I'm getting here is that I'm never using this. So that's looking good. Therefore now, finally, we can call setFetchedPosts to update the state and pass this blog posts array to setFetchedPosts. And with that, we'll then update the state, execute this app component function again, and we can now use the state with that blog posts component to output those blog posts. Therefore here, I'll return a main element and I'll actually output an image on top here for styling purposes. an image which we can import from that project which I provided to you. I'll name it fetching image, and we can import it from the assets folder, and there it's this data fetching PNG file. And this should now serve as the source for this image. And the alt text can be something like an abstract image depicting a data fetching process or something like this. But then, more importantly, below that, we can output that blog post component, which, of course, in order to output it here, must be imported from the blogposts.tsx file. And to that blog post component, we can pass this posts prop, because that's what this blog post component is expecting in its props object. And that then wants an array of such blog posts, which conveniently is exactly what we're storing in our state here, in this fetched posts state. Now I'm still getting an error here though, because this state could also be undefined. After all, it's initially undefined. So therefore, I'll tweak this code a little bit, and I'll actually add a helper variable called content, which is of type React Node. So anything that's renderable in JSX. And that, of course, is imported as a type from React. And this is initially undefined, which is fine, but I'll then check if fetched posts is truthy. And if that's the case, I'll set content to my blog posts component that receives the posts. And here, of course, we then know, and TypeScript understands, that fetched posts is not undefined, but instead an array of blog posts. And we can then simply output content here. And if it should be undefined, that won't be a problem, but in our case here, it should be such a blog posts component. So if you save that and you reload your app, you should see a bunch of dummy blog posts fetched from that dummy backend. So we're able to fetch our posts here, but of course, in reality, this is not always going to be super fast. We might need to wait for our backend for a couple of milliseconds or seconds. And therefore, we might want to show some loading fallback text whilst we're waiting for a response. And of course, things can also go wrong. And I want to handle these two scenarios as well, therefore. Now let's start with the loading state. To handle that, we can add a new state to that component. A new state with help of the useState hook, of course, which is our isFetching state, which we update with setIsFetching. And initially that should be false. But of course, here, inside of fetch posts in that effect function, right at the start, we want to call setIsFetching and set that to true, because we're sending that request here. Of course, we then also want to set is fetching back to false once we're done here at the end. And then with set is fetching being called and being set to true or false, we can go to the component function and change the value of content if we're currently fetching. So we can check if is fetching is true, and in that case, set content equal to a paragraph with an ID of loading dash fallback, because I prepared some styles for that ID. And here we could then say fetching posts ... And we can see this in action if we go back to our page and open the developer tools, and then there if you go to the network tab. Because there in Chrome, you can throttle the network and simulate a slower network. For example, by simulating slow 3G. If you do that and you then reload, It will take some time to fetch that data because during development all these code files are extremely big and not optimized, but then you'll see that fetching posts text, at least briefly. And with that I'll disable throttling. But this loading text therefore is shown as intended. Now, to conclude this example, I also want to implement error handling, so that if sending this request fails, the app doesn't simply break, but we instead show some error message to the user. Now, since we're using this utility function, which will throw an error if we get back an error response, all we have to do is wrap this get call here into a try-catch block. Like this, where we catch an error. Of course, the code that depends on the success of this fetch request also should go into the try block now, though. So here, where we update the fetched posts, that should also go in there. This code here, where we set isFetching back to false, should however stay outside of the try-catch block, because no matter if we got an error or not, we're not fetching anymore. Therefore, this should definitely be set to false again. And it's now here in the catch block where the error should be handled. For this, we can add a third state, an error state, which I'll name error, and a set error state updating function. And this should eventually be a string, or undefined, which is the initial value. And then here in the catch block, we can set this error state by calling setError. And we can set it to a message like failed to fetch posts, like this. We could also use the message of the error that's being thrown. So for example, of this error, where the message would be failed to fetch data. Now for that, we have to access this error object that's being caught here and use that in our setError state updating call. And for example, set this to error.message. The problem with that just is that error by default is of type unknown, because TypeScript doesn't know what it's catching here. In JavaScript, you can throw anything as an error, including numbers, strings, anything. So TypeScript doesn't know what type of value it will get here, and therefore we either have to add some checks here and check if error, for example, has a certain property, or if the type of error, for example, is a string or something like this. We can do all of that, but for this application here, we know that it will be an error object. Therefore, we can also just use typecasting here and tell TypeScript that this will be of type error. Alternatively, and a bit cleaner, we could add an if check and check if error is an instance of the error class. This is another operator that's built into JavaScript and that can be used to get true if error is based on this error class, which is built into JavaScript, or false if it's not. And that would then also allow us to access the message property in a safe way. And that's arguably the cleaner way, so I'll use this approach here. With that, we can then use this error state to show an error message on the screen if we have an error. So therefore, we can, for example here, check if error is truthy, because keep in mind that initially error is undefined, which would be falsy. So if it's a string, if it has some content, it will be truthy. And if that's the case, content should be set equal to that special error message component, which I already prepared for you, which wants a text prop. So here we can set content equal to error message. For that, of course, you must import this component. And then here we can set the text prop to error, like this. And with that, we should also be handling errors. So if we now deliberately break the app by sending the request to an endpoint that doesn't exist, and we then save this, if I reload here, I get this error box. So that works as intended. And of course, if we go back to the valid API endpoint again, /posts, and we then save this and reload, we got those posts again and the error is gone. And there also is no error here in the console.